Welcome to new KNEW 9 Polynomials Special Cases Guided Video Tutorial. So you've already watched the review for adding and subtracting polynomials and also multiplying, so the distributive property, whether it be distributing 1 or the double distributive property, which used to use the mnemonic device FOIL. So let's get started. So we're just going to continue on with these special cases. You'll see in a second why they're special cases. We're going to use the same technique using that double distributive property. So remember, when you have these two parentheses with two terms each, the binomials we talked about, we named them last time, you're going to get those 4 terms, right? So if we mark that out for ourselves, remember, you haven't seen it in a while, but I am all about those templates. We're going to make this template, and then we're going to see what happens. So we distribute that x out to the second parenthesis, and we get x times x is x squared. X times positive 7 is positive 7x. Then we're going to distribute this negative 7 to the second parenthesis, and negative 7 times x is negative 7x. Negative 7 times positive 7 is negative 49. Now 49 is a perfect square. That's going to become more important in the new NEW section of this week, but I'll leave it for now. But just start to think about anytime you're multiplying a number by itself, so 7 times 7, 8 times 8, 12 times 12, that gets you a perfect square number, okay? If you take the square root of it, you would get a number with no decimal. When you go to simplify and combine like terms here, you bring down the x squared, you bring down the negative 49. When you combine these numbers, okay, positive 7x, negative 7x, they knock out with one another. So you get a 0. And ultimately you get x squared minus 49. That is why this is a special case, okay? So ultimately, like the inners and the outers, okay? If I look at this again, I'm just going to rewrite it because it's all marked up here. If I rewrite the given, so this is just what I had up here, right here. This piece here, this negative 7 times x, and this x times positive 7, like this double rainbow upside down. You see it? It's like it's a rainbow, but it's upside down right here. Those are the pieces that cancel out, right? Because negative 7 times x gets me negative 7x, and x times 7 gets me positive 7x. So that is the piece, those are the pieces that knock out here and here. Those are the pieces that disappear. The pieces that you keep then are this and this. So let's see if that happens again or if that was just a coincidence. 1, 2, 3, 4. Okay. X times these two, I get x squared. I get negative 10x. I do these two, I get positive 10x. I get negative 100. You see right away, these are canceling because I have negative 10x, positive 10x. And when I simplify, I get x squared minus 100. If I look here, and maybe I'll just be able to erase this, okay? These are the ones that are knocking out. These are the ones I'm keeping. So you can pretty much start to kind of build your case for when I see inside my parentheses the same numbers, x and 10, but one being positive and one being negative, okay, I don't have to do those inners and outers. I just have to do the firsts and the last. What do I mean by that? This is an inner. These are my outers, right? These are my firsts, my first numbers, and these are my last numbers. All right, so let's try it with this. I do 4x times these two. I get 16x squared minus 4x. I do these two, and I get positive 4x minus 1. These two knock out, and I get 16x squared minus 1. And I'm done. Now, exponent, we have to jump back to exponents for a minute because our exponent rule said that when I had an exponent on the outside, I could just bring it in, right? Wrong. And you might be saying, why? What the heck, right? Well, okay, why is this? What is different about it? When we were allowed to do that for exponents, here was the situation. This is what our exponent rule said. And we were allowed to bring it in and in. And we were allowed to do this and this. What is the difference between this one and this one? Well, this one has a big fat plus sign. And that big old plus sign changes things. Addition messes everything up. Now, you guys are not in high school anymore, so I can't use this, but like when I taught high school and I taught this in high school, when I would always say like, and any of you who are parents now can appreciate this, addition is like dating in high school. It messes everything up. And I'll tell my kids like that till I'm blue in the face, because I don't want them dating in high school. All right. Addition is like dating in high school. It messes everything up. Multiplication, it's like, it doesn't mess anything up. It's usually clean and like nice clean breaks. Like the rules work and whatever. As soon as you throw addition into the mix, it's like it gets messy. Okay, which in my experience teaching in high school, it's just not a fun time. So you don't want addition anywhere near any of your problems. Like if you can do things without adding addition into it, no pun intended, it's going to make things a lot easier on you. So with this one, you can't just put the exponent into it. You have to do it a different way. And the way you have to do it is this. This exponent is literally saying you have this thing twice. Okay? So it's saying you have 2x plus 5, 2x plus 5. So as soon as I see that, like, somehow I got on highlighter. Oh, making more of a mess than I want to. All right, so as soon as I see that this, I usually go like this. Okay, I know I did that down there, but I'm just showing you. I usually literally just cross it out and rewrite it. So that's what my paper would look like. Okay, so then I can follow my rule that I go, do my thing. I write out my 4 things and I do this. So 2x times 2x gives me 4x squared. 2x times 5 gives me positive 10x. I come down here and I do the same thing and I get positive 10x and plus 25. I bring this down, I bring this down, I combine those. So I get 4x squared plus 20x plus 25. And I'm all done. All right, so we get another chance at it. So again, I'm going to show you exactly what I mean, how I would do it. I'd do that, and then I'd just do, well, I would not make up my own problem. You're going to write the exact same thing. Don't make my mistake. Okay, and then I would draw out my 4 things, my 4 term places, slots, my template, and then I would start. So 3x times 3x is 9x squared. 3x times negative 7 is negative 21x. Negative 7 times 3x gets me minus 21x, and negative 7 times negative 7 gets me positive 49. Okay. Down we go, these combine. So I get 9x squared minus 42x plus 49. All right, so number 6, 7, and 8, they're all going to be your challenge problems. You're going to go about them the same way. So if you think about it, like, why do you get 4 slots to figure out number 6, how many slots you need? You get 4 slots because you're taking this, if I do it in another color, you're doing this and you're getting 1, 2, right? You get 1, 2, and then, so you get 2 from that one, and then you get 2 more from that one. So let's think about how many slots you'll need for this next one. From this guy, you're going to get 1, 2, 3. And then from here, you're going to get 1, 2, 3. So you're going to get 1, 2, 3, and then you're going to get 1, 2, 3. So you're going to get 6 total slots. So let's just start going for it. All right. X times x squared is going to get you. So if you have x and then x squared, so 1x and then 2 more x's, you're going to get x to the 3rd. X times negative x, so that's going to be negative x squared. And then x times positive 5 is going to get you plus 5x. All right. Now here you get negative 3 times x squared. That gets you negative 3x squared. Negative 3 times negative x is going to get you positive 3x. And then negative 3 times positive 5 gets you negative 15. All right, so now your numbers won't line up as nicely as in the ones where you just do the double distributive. So, like the x to the 3rd doesn't match up with any other 3rd one. And usually the first and the last, they'll be good to go. Like they won't have anything to combine with them. X to the 2nd, here's another x to the 2nd. Just an x. Here's another just an x. And then negative 15, there's no other one. Okay, so writing this out, I have x to the 3rd. I owe you $1 and then I owe you 3 more. So I owe you $4. I have $5 and I have 3 more. I have $8. And then minus 15. And I'm all done. All right, so going along the same logic, I should have 6 terms, but let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so now I take the x, and I have x times x to the second, so I add the exponents and I get x to the third. X times 4x, and I get plus 4x to the second. And x times 2, and I get plus 2x. I'm going to come back around and do the negative 5. So negative 5 times x to the second, and I get negative 5x to the second. Negative 5 times 4x, and I get negative 20x. And negative 5 times 2, and I get negative 10. So now I'm going to go... Sorry, minor interruption from my daughter. So now I'm going to go through with my highlighter, and I'm going to figure out where my like terms are. So again, like I said, usually it's the first term, not always, usually it's the first term and the last term that don't combine with anything, and some are out of order. So this x to the third doesn't combine with anything. 4x squared combines with negative 5x squared. 2x combines with negative 20x, and then I have this negative 10 on the end. So I'm going to go back and write. And again, this is just like an etiquette thing. It wouldn't necessarily be marked wrong per se by me, but in multiple choice questions, it's how you'll see it. And I can't speak for any other teacher. And given the directions, like it might say in descending order, if it says in descending order, it will want the biggest exponent first, and then like, you know, in this case, 3, 2, 1, and then no exponent. So x to the third, then I have to the second, you know, I have $4, and then I give somebody $5, so now I owe $1, so minus x to the second, or minus 1x to the second. And then x, I have $2, but then I owe somebody $20, or I give somebody $20, I end up owing 18 x's, and then minus 10. So that's my answer. All right, so this one, I don't know if I left quite enough room for myself, but ultimately, I am not, I have these 3 things. I can only worry about 2 at a time. You know, it's like your mom told you when you were growing up, like worry about what you can, or worry about what you can control. You can only worry about one thing at a time. So I'm going to, it doesn't matter which 2 things I pick, but I can only do one thing at a time. So I'm going to look at this. All right, and I'm only going to look at this. So with that, I know when I just had a binomial, by a binomial, I had 4 things. Okay, and when I did that, I did x. Okay, and then I came back and I did this. And what would I get? Well, x times x got me x squared. X times negative 1 got me negative 1x. 3 times x got me positive 3x. And 3 times negative 1 got me negative 3. I came back and I combined these. So I got x squared plus 2x, because 3 minus 1, and then minus 3. Okay, and then I had to bring this down, 3x minus 8. So now it looks more like one of those. I am going to rewrite it though, because I want my binomial first and my trinomial second. So I'm going to rewrite it 3x minus 8, x squared plus 2x minus 3. So I'm going to take this and I'm going to go boom, boom, boom. So 1, 2, 3. Then I'm going to come back and do boom, boom, boom. 1, 2, 3. And here we go. All right, so 3x times x squared gets me 3x to the third. 3x times 2x gets me positive 6x squared. 3x times negative 3 gets me negative 9x. Okay. Negative 8 times x squared gets me negative 8x squared. Negative 8 times 2x gets me negative 16x. Negative 8 times negative 3 gets me negative 24. Combining, this I can't touch. 6x squared, negative 8x squared, negative 9x, negative 16x, and I'm highlighting, negative 24. 3x cubed, negative 2x squared, negative 25x, and then minus 24. And I'm all done. This is the end of your review for this week. We will be moving on to the new section in your next video.